So this is our third lesson on implicit differentiation, which is chapter 11. One big difference between the questions we were doing last lesson and the ones we're doing this lesson is this. And the reason these questions are different is what we have here is we've got the variables multiplied together, which we didn't have in the previous lesson. So what that suggests is that we're actually going to use our product rule for these questions. So how we choose to split this up doesn't really matter too much which term the 2 goes with. So 2x could be one term, and then y cubed could be the other term. We certainly don't want to call one term 2 and the other term xy cubed, because then we still have a product rule. So first of all, we do our setup, just like we did before for the product rule. We differentiate each one, so differential of 2x is 2. Differential of y cubed from last lesson, bring the power to the front, decrease the power by 1. And as it has a y in it, we're going to call that dy by dx as well. Then we can use our product rule. And product rule is also on the formula sheet for AICE as well, so you don't need to remember this, you just need to know how to use it. And then we're just simply going to substitute in our 4 terms into that formula. And for this one, that's as much as we can do. There was no equals question, no equals term for this, it was just differentiate. So we're not going to rearrange, and that's all we're actually going to do for this question. Now when we get to our next question though, this looks a little more similar to what we did last lesson. We have an equation, we want to find a specific gradient. So the only difference with this one is we have our product rule in here. Now I noticed after I'd actually prepared this, what I could have done here is I could have divided both sides by 3 and just had x to the 4 y squared equals 16, and that would have been a much better way of starting this question. However, we don't always notice things like that, so I split it up like this, 3x to the 4th and y squared. Differential of this one is 12x cubed. Differential of this one is 2y dy by dx, because there's a y involved. And then we're going to use our product rule. And differential of 48, with 48 just being a number, differential of that is just 0. Then we're trying to find a gradient, so we want to know exactly what is dy by dx. So we're going to rearrange this equation so that positive 12x cubed y squared moves to the side and becomes negative, and then we can divide by 6x to the 4th. Some simplified we can do here, x cubed divided by x to the 4th is x to the negative 1, subtracting the exponents, so we can bring that to the bottom. And then y squared over y is y to the 1, or just y. In the original question, it tells you that x is negative 1 when y is 4. So if we substitute those in, then we can actually find that the slope is 8. Now this question could easily be extended as well. We could be asked to find the equation of the tangent, as we have a slope and we have a point. It could be find the equation of the normal as well. Negative reciprocal for slope, and so on. So this question could be one that's easily extended. Now we're going to do the same question again, but in a slightly different way. Now when we first did our rules for solving equations, what we do to one side of the equal sign, we must do to the other side. So what I'm going to do for this time is I'm going to take logs of both sides. Now that might not seem very obvious why you want to do that to begin with, but we have a product here, and using our rules of logs, the log of AB equals log A plus log B. So we can actually split this question up. We can also take this one step further as well with our rules of logs. Any powers we can bring to the front. And then now when it comes to differentiating, it's much simpler. Now the rule for differentiating the ln function is you differentiate what the ln is, and then you put it over the original. So differential of 3x is 3 divided by 3x. Differential of y is 1 dy by dx, because there's a y involved, and then over the original. And log of 48 is just a number, so when we differentiate that, we just get 0 again. Once again, solving for dy by dx, we can bring this term to the other side. After I simplify, 3 over 3x is just 1 over x. So bring that term to the side, make it negative, and then instead of multiplying by all this stuff, we can divide by all that stuff. And actually we end up with exactly the same slope if you want to check back to see. So when we substitute in, we'll end up with exactly the same answer. So rules of logs can actually make these questions a lot simpler if you actually recognize that. So one to keep an eye out for.